Hey everybody, Cole here with Classic Mini DIY, and on today's episode, we are going to be talking about something super special, a power distribution module. So stay tuned for that. All right, welcome to the next episode of Classic Mini DIY, as well as the next episode of the fuel injected conversion I'm doing on my Turbo Mini. Now, on today's episode, we have a few things to do. One, we are going to be prepping the wiring loom to suit exactly my application and the things that I'm going to be running on my car, which likely will be similar to the things that you're going to be running on your car if you were to do this conversion. And then we are going to be preparing my loom and swapping it over to use something extremely special, which is a PD16 power distribution module. This is something that is relatively new. The idea behind them is that you have, instead of fuses and relays and all sorts of other complex wiring, or at least lots of wiring, you replace all of that with one single unit. Now, I'm going to talk more about this in a minute and what this does, how it works, and why I'm going to be using it. But before we get into it, I just want to remind you guys that I'm doing this build a little bit differently than the ones previously. I'm taking an approach called You Fund It, You Win It. And for anyone who becomes a patron during this build, you guys will be helping to fund this project, which means that a lucky winner, a lucky patron, between when this series started and when it ends, will get to win a full EFI conversion for their car. That will be, depending on the funding levels that we reach, either a Haltech Elite 750 with a premium wiring harness, or if we end up getting a little bit higher and we end up hitting some of the higher goals, it will also include this beautiful new PD16 power distribution module, as well as the harness to go with that. And the kit will also include one other special bit of equipment that I am keeping a secret for right now, so you're gonna have to stay tuned to find out what that is. Now, getting back to the actual hardware that we're talking about today. On the last episode, I talked about the Haltech ECU, why I'm doing this, some of the things to think about, and the sensors that you might need to get started. Now, on today's episode, I am adding a new piece of hardware, a power distribution module, to the Elite 750 hardware ecosystem I've got going on here. And as you can see, we have the Haltech Elite right here with its hot wiring harness. Now we have an entire secondary wiring harness, and let me tell you, this sucker is a chonker. And this is the secondary harness that goes with the PD16. Now, before we get into modifying this harness to accept this harness and doing all of that stuff, let's talk about what this is. Now, there's been a concept in the motorsport world for a little while now called a power distribution module. But for people who wanted to put this in their cars, they needed a set of complex skills in order to program these, get them to set up and work with your existing ECUs, all sorts of different stuff. And it's not impossible, but it was definitely hard work. Now, what Haltech has done is released a brand new unit, this right here, and unfortunately it is not a very cheap unit. I'm just gonna warn you guys right now. But what this does is it becomes the brain for all of the power that's running through your car. So whether you are powering sensors or fans or your fuel pump, all of those can be triggered directly through this unit. And I am going to superimpose part of Haltech's video on how this is going to replace what you have in your car currently.
Traditionally, when using a relay to switch a high current device, the 12-volt power supply would come from the battery positive terminal through a fuse to pin 30. That supply goes through a high current switch inside the relay and out of pin 87 to the high current device you'd like to control, something like a fuel pump or a thermofan. In order to switch the high current side of the relay, we need a low current switch. This is typically a ground switch from the ECU to pin 86. Pin 85 of the relay would be connected to the switched 12-volt supply to complete the circuit. And this is how, with the aid of a relay, you can use a low current switch or ECU output to turn a high current device on and off. Now, things get a lot simpler when you start to use the PD16. A single power cable runs from the battery positive to the PD16 power lug. Then, a single high current wire runs to the device positive terminal, and that's it. So if you're moving from a traditional fuse and relay block setup, all you need to do is remove the wire on pin 87 from your old relay setup, crimp a pin on it and feed it into one of the outputs on the PD16 connector. Then, that's it. You simply chuck out the rest.
Before, you would have a set of relays and switches and fuses. Those all would live in your car. You guys are probably familiar with those, or at least have heard those words in the past. Fuse, obviously, is a protection for your circuits in your car. And then your relays are what are going to be triggering high amperage circuits with a low amperage circuit. So you have a switch maybe on your dash, you flip that switch, it tells the relay via electricity that it needs to toggle. And then there's a mechanical toggle that actually clicks and allows the high amperage current on a separate circuit to go through the relay and into whatever you're trying to run. So for this setup, this PD16 is completely removing those fuses and relays and replacing it with solid state drivers that behave like fuses, and these circuits can handle high amperage loads. So instead of having all of those wires, now you just have one unit that has a single 12-volt signal or 5-volt or whatever signal you want to have coming out of this PD16. That high amperage or low amperage circuit can now be powered and controlled through this unit and by connection your Haltech ECU via the CAN connector. So that's a lot of information, but what does that all mean for a Classic Mini? Well, in my setup, what I'm going to be doing is doing a almost complete fuse box and relay removal in my car. So I have things that are powered off of the ignition. So when the ignition switch gets turned on, e.g. you start the car, you have sensors that turn on. You have an air fuel gauge that might turn on, a lambda sensor, all sorts of different stuff. You can basically power anything that you want to off of this unit right here that's ignition based. And the cool thing about these is that you have 4 25 amp circuits, which is quite a high amperage, and then you have 10 8 amperage circuits. So this is going to allow me to effectively totally reduce and remove all of my fuses, all of my relays. And you might be wondering, well, Cole, if you remove your fuses, if your circuit blows, does this unit get totally damaged and destroyed? No. The cool thing about this is that it has built-in solid-state drivers that behave as your fuses. So if a fuse blows, if it goes over current, this will trip that solid-state driver. And then in the ECU, all you have to do is reset that solid-state driver and boom, you have a brand new fuse. I'm doing air quotes because it's not a traditional fuse. Obviously, it's a brand new concept and something a little bit more resilient and reliable. Now, to build off of all of that a little bit more, you can also monitor current draw and you can deliver different levels of current to each of these circuits depending on different factors. So a perfect example on a Classic Mini is a supplementary electric fan. Lots of people add these fans into their inner wing if you live in a really hot climate. And then that fan you might toggle on manually when it starts to get really hot, or you might have it on a manual thermostatic fan switch or a thermostat that lives inside your radiator. What you can do with this is something pretty cool. So instead of doing a manual switch or anything that we had just mentioned, what you can do is trigger this fan to spin up at different temperatures based on your coolant temperature sensor. So let's talk about Celsius. Maybe it starts to get about 50 degrees Celsius and you want a little bit of fan to kind of kick on at that point. So what you can do is deliver a lower amperage or a lower voltage to that fan so you don't spin up the fan to its full speed at all times. And it gives you this modulation. So let's run the fan at 50 degrees at 25%. But okay, it's at 75 degrees Celsius now, starting to get a little bit hotter. Maybe I want the fan to run at 50%. And then I change that, I trigger that. And then once my coolant is up to temperature or starting to get really hot, maybe we want the fan to run full bore 100%, and we program it to do that. And it's all done very simply through the ECU software, so you don't have to have special programming skills or anything like that in order to get this working for yourself. So that alone is a huge, huge thing. And you can do that with multiple different sensors. You know, maybe you have a idle air control sensor, or, you have a, whatever sensor you have on your car, you can do really cool, complex things. So in my case, I'm going to be replacing all of the circuits I can and putting them through this unit instead of individual relays. It's going to make the whole system a lot more reliable. So with that out of the way, let's talk about why I have another enormous harness that came with this PD16 and what I'm going to be doing with it. Now, one thing I did want to touch on about this unit right here before we get deeper into this is whether or not you actually need this on your car. And I would say that depending on your application, you may or may not need this. This is not something that I would encourage everyone to buy and everyone to replace on their car. But if you are running a Haltech ECU and you want to simplify your system, you're building it from scratch maybe, or you want to get, modernize things in your car, this is a really, really cool way to do it and something that's definitely worth doing. But if you are running an EFI car, you do not need this in order to run it properly. This Haltech 750 Elite is going to work perfect. It's not going to need anything else on this. This is only something that I wanted to show you guys because it's really cool, and I think that it's basically going to be the future of car electronics in many ways. Not specifically just the Haltech unit. This is obviously aftermarket, but we're already seeing power distribution modules start to show up in modern cars like BMWs, Audis. A lot of the kind of higher end cars are starting to introduce some form of power distribution. So if you have a premium harness like this that came with your Elite 750, which I would strongly recommend picking up if you're going to be building this yourself, whether or not you use this PD16, you have a fuse box here. Now, I've already taken the cover off here, but what we are going to be doing is literally deleting this. So this is going to get removed. It's going to get chopped right out, and we're going to wire in with Haltech's wonderful instructions. This is one of the reasons I love Haltech, is their documentation. We're going to be taking all of these wires and running them through the PD16 unit, completely deleting this fuse box right here, even though this is a very, very nice fuse box. One thing that I would love to see Haltech do in the future is bundle these things. So if you wanted to get an ECU with a PD16, you could say, yes, I am getting a PD16, and you can choose to buy a wiring harness that's already pre-configured for this, as opposed to having to modify it at the end. This isn't the end of the world, but it is, more work. So first things first, let's modify this harness and remove the stuff that we don't need so we're not overcomplicating the swap over and over to the PD16. Now, one thing I want to mention before we get into depinning this harness is how this relay box works. So each of these pink wires is kind of daisy chained off of each other. And pink in the Haltech world, or at least in these ECUs, check your wiring manual just to double check this. But in the Haltech world, this is your ignition wire. So this would be triggered off of like your key switch on your car. So you turn the key and then you get 12-volt signal. And then everything that this 12-volt ignition line is running to is going to be flipped on during that initial click of that switch. So from the factory, from the Haltech factory, you have two relays set up with two fuses. So your ignition line comes into the relays, triggers the relay, and then you have your two fused circuits going into those two relays. And that is, once that ignition switch happens, the relay clicks on and allows the power to run through these red lines through the relay and into the actual units on your car. In this case, this is configured for a fuel pump and for something else. I forget what it is, but basically you have two circuits. The ECU itself. So you have the ECU power and then the fuel pump power. Now, you don't have to use this for a fuel pump, but that is what they have it pre-configured for in the kind of like generic setup. Now, in our case, we get to do the really fun job of literally getting to cut these wires. I'm gonna cut them right out. So we'll expose all of our wires here. We have a wide array of wires going into and out of this unit, but what we're gonna do is just go ahead and cut them. Now, this feels really weird considering I just bought this unit, but This is what the Haltech instructions say. But the cool thing is Haltech actually includes a really wonderful wiring diagram, and you can see here, this talks about how to modify your existing premium harness to use the PD16 properly. So you can see there's the old fuse box on the right side, and then the PD16 on the left side with the new wiring connections. If you're doing this at home and you're not sure what's going on, you're not sure if you're doing this right, you can always reference that and double check that your connections are being correctly connected. So there we go. Goodbye, fuse box. All right, so this is where things start to get a little bit more complicated. And this is gonna vary depending on which Haltech ECU you have. In my case, I've got the relatively simple Haltech Elite 750, which means I don't have quite as much rewiring or crimping or anything like that that I need to do with these setups here. Now, to get started, we are going to go ahead and remove some of the wires that are not going to be necessary with this new setup and with the new powering system. And this is one of the nice things, as I mentioned before, about moving to a PDM, is that you get to remove wires, things that are not necessary in every setup. So to start off, there are two big primary wires that we don't need anymore. These originally were used as the power feeds for the fuel pump and the main ECU. Since all of that's going to be coming from the distribution module now, you don't need these. It's actually pretty cool. And it's really nice to be able to simplify wiring systems. So to remove those power feeds, let's just go ahead and loosen up this stuff here and find our leads. So as I mentioned, the wiring diagram that comes with this ECU and with the PDM will tell you which ones to remove, but just for your reference and to make this a little bit clearer for you guys on the video, we are going to be removing the red and green wire and then the red solid wire. These two are going to just be completely removed from the harness, and they should slide out with relative ease. I like to keep this wire around because this is probably going to be better wire than you can find in your local hardware store or your local automotive parts shop. Having this wire around and the original wire color references is kind of nice in case you want to revert it back or add it back for whatever reason in the future. So, gonna bundle that up and stick it out of the way here. And now we are left with a slightly lighter wiring harness, which is great. And we're left with a collection of other wires here. Now the first one we're gonna do, and we're gonna start this off by unraveling this enormous spaghetti monster of wires. Woof. These wires are enough to stretch from like the front of a pickup truck to the back of it. That is crazy. So with the wiring harness that comes with the PDM, a lot of this hard work is done for you, which is just wonderful. And the swap over ends up being a lot less complicated. But I'm gonna superimpose this on the screen just so you guys have a reference of what I'm looking at. So we're just gonna start off going straight down the line of the swaps over to the new setup. And the first one is our ignition 12 volt. This is going into the HC01 output, and that is our blue and red wire. Now, the way I'm gonna have this PDM and this ECU configured in my car, let's go ahead and plug this up here. So I have the PDM. This is going to be living on my bulkhead, and then the ECU is going to likely live right next to it. So these wires don't have to be super long. They don't have to stretch across, miles and miles of distance. Like, they are going to be kind of bundled up out of the way, very clean and tidy, right up there on the bulkhead. So this blue and red wire doesn't actually have to be super duper long like it is right now. So I'm gonna do a little crimp here, and I'm gonna leave a little bit of excess. We're gonna chop it off right about here, just like that. And just like the other ones, I'm gonna go ahead and remove this excess. I'm gonna set it aside and bundle that up for later so that it can be used, if we want to use this in the future. There we go. So there's our excess for the blue and red wire. I'm going to put that out of the way. And grab the new shorter connection. From the Haltech ECU wiring bundle, you're gonna have a still big collection of wires. Now what we're gonna be doing is combining the blue and red line, which should be in this high output connection here. Now I had to rearrange these wires because it was taking up a lot of room on my desk right here, but we're gonna go ahead and strip this off right here. Not too far off, there we go. Go ahead and strip that, and then we're gonna be combining this into two wires. There are two blue and red wires here. They are going to need to get spliced and crimped as well. Now there's different ways that you can do this. If you want to, you can completely remove and depin this big wire here, the blue and red. And then you can simply pin the two smaller wires directly into your HCO plug over here on the PDM. All right, so there we have it. Our first connection has been made between the main harness and the PDM harness. Next up, we're gonna move to the ignition 12 volt, which is a yellow and red wire. Now, just like the other one, I'm gonna cut this one down just a little bit. The wires that come with it are extremely thick. They're a very thick gauge wire. You won't need that probably for most applications. You definitely won't for the Mini's fuel pump. It's not a high current pump, but for some applications, you might need that additional thickness. Now, I'm gonna go ahead and clip that. That is yellow and red, and we're gonna do pretty much the same thing we did before here, except we're only crimping 1-to-1 wire here. So no special additional crimping or anything, no dual wire crimping, that is. All right, so now we have our two connections, one for the injectors and one for the ignition. All that we have left is our final fuel pump connection. And this one I'm actually gonna approach a little bit differently. Since this fuel pump line is already really long on the PDM harness and it's already really long here, I'm not actually gonna crimp this or connect these two wires. I'm simply going to run the new wire down the same length of this harness so that we can run that out to the fuel pump connection, which is probably going to be somewhere in the front where the old fuse box used to be. But for the fuel pump, we're just simply going to remove this wire entirely since we have a brand new one with the PDM. Now, you might be curious, well, Cole, when you remove this fuel pump connection right here, aren't you then removing the ECU's ability to control this? Well, luckily you aren't with this setup. It's one of the beautiful things about this PDM. Each of these circuits inside the PDM is user definable, so you can actually control these things through the ECU, which is connected via the CAN bus. Since the PDM is connected to the ECU, the PDM is controlled by the ECU. So all the circuits that we have on this new unit are also going to be usable and programmable and all of those different things directly from the ECU like it was before. You're just gonna have a much simpler setup now. And so I'm gonna go ahead and add a label to this just so that I know what it's for in the future here. So as you can see, things do kind of get a little confusing as you're going through these and running different wires and running different directions and all those sorts of things. But in reality, you're really just doing a one-to-one conversion on a lot of these lines. And you can see now I have run my high amperage lines through the main harness. That's this one right here. This goes into the actual ECU. And then you have a connecting line that comes, it's kind of laying down behind me here, of those high amperage lines that are going into the PD16. So now the ECU is going to get power properly, the fuel pump's going to get power properly, and the injectors are going to get power properly. So that's all looking really good. The only thing that we have left now are a couple of wires, well actually 4 wires still living in this harness that we need to find a new home for. And for the most part, these are going to be removable. You're not going to need them anymore. One of them was the relay ground here, and that's a shared ground, so you're probably going to find that it has that it's paired with another connector in here. So the main thing is that when we cut this one out, which I'm going to go ahead and do right now, we're going to go ahead and snip this as close to the crimp as possible. We'll go ahead and remove that ground. Bye-bye. Probably don't even need to keep that wire, that's too short. We're going to want to insulate this wire down here, just to make sure that we don't have an improper ground being connected. Whenever you expose wires, it's always a really good idea to go ahead and just cover and insulate any bare copper that there might be. It's probably a little less dire if it's just a ground, especially a shared ground that's in a bundle like this, but it's a really good practice to get into. So if you're doing wiring like this, just go ahead and do it and keep yourself doing best practices, because when you do something, if you're gonna do it, you should do it right. So now what we're left with is simply 3 wires. One is the pink ignition line. This was what would trigger all of the different relays inside this fuse box when you would turn the key on. So you have your old relay box here. When you turn the key, the pink line would trigger all of those relays and say, hey, turn on, and then they'd make their connections. Since the PDM has its own ignition switch wire, I'm just actually going to totally remove this one. This is not going to be needed in this part of the harness anymore. Next up, we have a yellow and black wire. This was previously the fuel pump relay. This is coming from the DP05 on the ECU. You can reallocate this if you'd like to. You can use it to trigger something else when the ECU comes on, or program it to do something else. In my case, I've got a small setup and I really don't want a bunch of excess wires in my setup. So I'm actually going to completely depin this one. I'm going to go ahead and pull that out just so that we can do them both at the same time. And then we were left with a 12-volt signal, which was used in the fuel pump relay circuit as well. That is going to come out, and we're going to go ahead and remove that and depin it. All in all, we're just trying to simplify this wiring as much as we possibly can. And just like the ground circuit, we're going to go ahead and clip this. This is on a common connection. We're going to go ahead and clip that really close to the insulation. And just like the other one, we're going to insulate it as well. All right, and just like that, our 2 wiring harnesses are ready to be connected together. And I'm going to go over this one more time. Let's zoom out a little bit, and I'm going to talk about it one more time just to make sure that you guys are feeling confident in the things that we just did. Alrighty, so that was a lot of little wiring stuff. And now you guys can probably see why wiring is a really difficult thing to film. But the TLDR of this whole setup right now is that we took the Haltech 750 Elite with the premium wiring harness that came with the premium fuse box. We removed the premium fuse box and added an even more premium fuse box, effectively, called the PD16. This is a power distribution module, and this came with its own premium harness. I cannot recommend enough that you guys pick up the harnesses with these units if you're going to do it yourself. It saves you so much time and so much headache, and it makes the whole setup much simpler. What we did is we completely removed the power circuits for the injectors, the ignition, and the fuel pump, and connected those directly into the PDM. Then we removed the ignition switch wire, which basically, when you turn your key, would tell the ECU that it needs to turn on, as well as all of the other relays inside this box here. We removed that, and now that is all controlled through the PDM. It has its own ignition switch wire, which is still a pink wire that comes off of this main harness and goes into this unit. Then this gets powered by a single large 12-volt connector that comes directly from the battery. There's no, running it through, does it need to be in a fused slot, anything like that. You simply have a hard line directly from your battery positive terminal, or in the Mini, maybe the alternator connection would be a good connection spot for it. And that delivers this power at any time, with the ignition switch connection telling it when to turn on. Then this unit communicates with the ECU via a CAN port. I don't have the connector cable yet, it's on the way over here, but effectively you connect these two together, and then the ECU knows when this is on, and then it can manage all of the connections that are coming off of it. Now, the only other thing that I might consider doing today is removing some of the additional outputs on this PDM. There are a ton of connections on it. The whole idea behind this is that it is a PD16, which means it has 16 outputs. And those outputs can be used for a wide range of things, whether they are 5-volt sensors, 12-volt sensors, fuel pumps, fans, all sorts of different things. In my case, most likely what it's going to be powering is my electric fan. It's probably going to power my turn signals, my headlights, basically anything that I would want to be controlled through an ignition-only source. So in the case of my Mini, I'm going to be swapping over all of my ignition-only sensors and systems over to this PDM. So what that would look like in my car is the electric fan for the radiator, the supplementary one I have. I'm gonna add my tachometer, I'm gonna probably add the radio, I'll add basically anything that I only want controlled with ignition. That is going to come directly out of this PD16, make it really clean, and then I'll also be able to manage voltages and amperage draws on all of those devices and have that logged to my ECU so that if there's an issue, I can figure out what's happening and where there might be something incorrectly working. So just like the last episode, I'm going to try and keep this a little bit shorter since it is a lot of information, a lot of complex information. If you guys have questions about what I covered in this episode, or you feel like I maybe made a mistake, please let me know. This power distribution module is something that I've never worked with before, so it's very exciting to try something new, but I very well could have made a mistake in this video. So I thank you guys so much for tuning in, and just a friendly reminder that this is a You Fund It, You Win It style build, which means that if we reach our funding goals, I will be giving away some form of an EFI conversion kit. Whether it's an ECU and the special part that I have not shared the name of yet, I'm very excited to. I will be sharing that soon, or that plus the PD16, which would be a very, very nice bundle and would save you guys quite a bit of money. So thank you all so much for tuning in, and until I see you guys on the next episode, you guys probably know the drill by now. Enjoy those minis and motor on.